Hey, what's up, guys? John here again. Today, let's take a look at this LeetCode problem here, number 418, sentence screen fitting. It's a very interesting problem here. You're given like a 2D screen here, rows times columns, and a sentence represented by a list of non-empty words. You need to find out how many times this given sentence can be fitted on the screen. So the way it's being fit is like this. First, a word cannot be split into two lines. Basically, you can only put one word into one row, and two consecutive words must be separated by a space in the same line. So, for example, here we have this A, B, C, D, and E, right? And the size of the screen is 3 rows, 3 by 6, and this is how we can fill in the words. So first is always starting from A, right? And then we start from B, C, and D. Okay, B, C, and D, and then since since all the words need to be separated by a space. So basically, for this in this case, there's no place for the E here. So which means we have to move E to the next. Okay, and then once we have E next, the next one will also be A here again, right? And then next to A is again is BCD, but BCD cannot be fit in the remaining into the remaining words here. That's why we have to move the BCD to the next row, and then the last one is E. So that's why the answer for this example is 2. Okay. I mean, so for this problem, a naive way will be basically we have an index. We have a current index for the current word. We have a word index, right? And then basically we loop through all the rows for all the rows in rows. And basically for each of the row, we try to fill the words, the remaining words one by one, right? And once we reach the end of the word index, the sentence, we start over from the beginning, right? And every time when we see when the word index is equal to the n minus one, and then we will basically we do answer plus by 1. Okay, and in the end, we simply return the answer. Okay, but then what's the then the time complexity for this problem is going to be basically it's going to be the row. Let's say it's going to be O of the m times n, right? Basically, that's the row times column, and if the row times column is big, then for example, if the rows and column they're all 10,000, and so the time complexity. So basically, this algorithm, this solution will most likely be a TLE. All right, that's basically the naive solution. Can we try to improve this solution, right, to a better time complexity? Mm, so the approach we're taking here is actually all we need to care is mm, if you guys watch those 3 lines closely, actually what we want to know is that what's the how many valid characters we have in total, right? In this case, so let's say and okay, so for the first row, the valid characters is the entire row, right? Because that's everything. Let's including this like space here, right? That's the total. Basically the entire first row is a valid row because basically we're utilizing every single space here, right? How about the second one? So the second row is the valid one is until here. So E space A space, that's our valid. That's our valid space. And the rest two is not, because we're basically discarding those two empty space. And the second row is also we're utilizing everything here. So with that being said, one of the ways we can do is basically we'll be getting the sentence length. So that the logic we're using here, we're gonna have like sentence length, and we're trying to concatenate the sentence, and and then every time we are at a new row, the entire row to the and also we have a valid length, total length. So basically every time we'll keep adding this keep updating this valid total length, and we doing this by every time we add the entire columns for each of the row. And after we add the current column to the valid total length, we can check uh, if we use the valid total length, the updated total length to do a modular by the sentence length, and then we will get a relative position for this current sentence, right? And if that relative index is empty, sorry, it's not empty, it's if it's a space, since when we are concatenating, when we create this sentence, you know what? Actually, I will start coding here. That may be easier for you guys to see what I'm trying to explain here. And so first, I'm going to have like sentence here, right? And then I'm gonna basically concatenating this sentence here by joining all the words with space, right? Basically, that's how we will be put those sentence in the screen, right? Join sentence, right? And then in the end, we'll be adding a space, and then I'm going to have a total length here equals 0. And now all I'm doing here is I'm going to have like arrange rows here, right? So every time when we add a new row, I add the entire row. Sorry, I add the entire column to the current length. Because I'm assuming I'm trying to see, okay, if this entire row can be utilized, right? Can be utilized. So how can we verify that? We simply do a check. So if the sentence of the total length do a modular with the length of, actually I don't need this one here. I will do a n length of s, okay, of modular of n. If this position, basically we're trying to see if the total length can be utilized entirely, right? By checking if we do a relatively position, if we're hitting like a space, right? So if we're hitting a space, then we know, okay, we don't need to do anything, because the entire columns can be can all be fit with some words plus a space. Okay, this thing equals to empty, right? And then we also need to do a total length plus one here. Why is that? It's because mm, it's because we are, let's say for example here, right? Let's say the total length is hmm, um, it's because every time when we finish one of the new words, we add a space in between, right? That's why because in the end, okay, so because in the end, what we will be doing is we'll be doing this total length to the modular of the n here. That's how we're gonna use the total length to get us the how many times we can fit the whole sentence into this screen. Since when we create uh, the sentence, right, we add space, and every time when we are at like a new row and we see, okay, so this relative position is space, then we know we have to add one more to compensate to match with the space we're adding for each of the word. Otherwise, let's say if the number if the total number is 13, right, and the total length we get might be 12 because we're not counting the space for this like n here because we're adding an n in the end. Okay, in the end and also on every word after each word. So that's why we need to do a total length plus one here. And if this index is not zero, right? So basically, if this thing is sorry, if this relative position is not empty, then we know okay we are right in the middle of the words. Basically, for example, in this case, it's gonna be a B, C, D, and we're at this position, maybe C here, right? And for in that case, we know okay, so this basically it means that we cannot use all all the positions, all the columns for the current row because we'll be cutting this word into two parts. That's why we have to go back, right? So we have to decrease the total length. How we are going to decrease total length? Basically, we do a while s dot total length minus one, okay, divided by n. It's not equals to empty, okay, and total length is greater than zero, right? That's the since we're doing a minus one here, okay, we don't want this total length to be negative. That's why we do a check here, total length minus one, right? Basically, will just keep moving our the total length backwards one at a time until we see a space, and then we know okay, so that's the true valid total length we can utilize by for the current row, right? And then in the end, since we have this total length here, we can simply divide it by the total length of the sentence, and we'll see how many what's the result of this. Okay, let's try to run it. All right. Yeah, I mean, this problem, it's not like a very common problem. So, I mean, if you were asked this problem in a real interview, you know, I honestly I don't think many people can come up with this kind of solutions at the first time. even for me, I didn't come up with these solutions. All I was trying to do is I was trying to use the naive way, which I will be for each of the row, I'll try to fill the words one by one, right? Until I couldn't fill the word, and then I moved to the next row. So for this type of the problem, I mean, you have to be I mean, even though okay, so even though you realize that okay, I just need to know what are the total. I think for to be able to come up with this kind of solutions, you have to be insightful, right? About, okay, so what's the essence of this problem, right? Basically, all it asks us is to find out the total, the total, the total valid, basically the total length we can utilize for each row, right? And once we have the total length we can utilize for each row, then we can simply like do a total length divided by the length of the of this the sentence that and then it will just get our result with just uh O of O of M, which is the rows, because here I think it's constant, right? It's limited basically. So here we have a rows of the time complexity for this will be M rows times what? So we're gonna have a while loop here, and the worst case scenario is the will be the longest word in the sentence, right? So basically, the time complexity for this one is gonna be the rows times the length of longest longest word, right? And if there's no super long word, we can just consider this one to a O of 1. So in total, it's going to still be the O of rows, right? Mm, yeah, I think. And okay, okay. After let's say even though you come up with this idea, okay, that I just need to calculate the total valid the valid length, you still need to be able to come up with this kind of tricky logic here. So the way we can count, we can verify like how many rows, like how many bits or how many space or like columns we can utilize on each row is depending on the if if any word if we can fit in the words uh, if we can fit in any words, right? The total words on all these places. And the way we're checking that is we use the total current length, we divide it by the n. And if this like the modular, it's it's just happen to pointing to a space, right? And then we know, okay, so then this row can be fully utilized. Otherwise, we just do a we just try to remove the space, the total length one by one until we have a space. Yeah. Okay, cool. I think that's pretty much I want to talk about for this problem, and just try to maybe remember this kind of idea of how to, I mean, check the space and how can we check, how can we fit the entire word list into a single row, right? And yeah, again, so I don't think this is like a commonly asked questions during an interview. I think it's good for you to understand the concept, the solution or the idea behind this problem. All right. Thank you so much for watching the video. Stay tuned. See you guys soon. Bye bye.